Okay, we're looking at some trig identities. We're going to prove, first of all, that the cosecant of 2x is equal to the cosecant of x divided by 2 times the cosine of x. Then we'll prove that the cosine of 3 pi over 2 plus x is equal to the sine of x. And finally, a trickier one, we'll prove that the cosecant of x over the cosine of x is equal to the tan of x plus the cotan of x. To do this first one, well, first of all, let's have a look to verify that this is true. So we're going to look at the cosecant of 2x, and we're going to graph it. So this right here is the cosecant of 2x. And below it is the cosecant of x divided by 2 times the cosine of x. And as you can see, the two graphs are identical absolutely everywhere. So if I change the order of them, you'll see, I don't know if this will let me here. Yep. So you'll see that they're identical. Okay, so how do we go about proving that? Now, in order to prove this, there are a few things that we assume to be true. Now, the things that we assume to be true, we can actually furthermore prove that they're true, but we have to start at some point. So we're starting out assuming that we have the compound angle formulas. And these compound angle formulas you can see here. So we can assume that the sine of A plus B is equal to the sine of A times the cosine of B plus the cosine of A times the sine of B, and so on. We're going to assume all of these to be true. I'm going to split this up so that we have a left side and a right side. And I'm going to independently manipulate the left side and the right side and then see if we can get them equal to each other. That's going to prove that the left is equal to the right. The cosecant of 2x is 1 divided by the sine of 2x. That's simply the definition of cosecant. The cosecant of theta is 1 over the sine of theta, just as the secant of theta is 1 over the cosine of theta. If you ever forget which one goes with which, I tell my students that if you spell secant backwards, you get cos. I mean, you don't, you get kes, but that looks a lot like cos. And that's how I remember which one goes with which. Secant of theta is the reciprocal of the cosine of theta, and the cosecant of theta is the reciprocal of the sine of theta. Okay, so on the left I have 1 over the sine of 2x. That is 1 over the sine of x plus x. Right? 2x is x plus x. And the reason why I'm doing this is I want to relate it to something that I know. I know how to deal with the sine of a plus b. So the sine of x plus x is the sine of x times the cosine of x plus the cosine of x times the sine of x. Well, they're the same thing. They're both the sine of x times the cosine of x. So this is 1 over 2 sine x cos x. Okay, over here on the right-hand side, I have the cosecant of x divided by 2 times the cosine of x. The cosecant of x is 1 over the sine of x. Now, I have a fraction as the numerator of a larger fraction. So I can write that as 1 over sine x to cos x. And if that gives you any confusion, let me do this in a few more steps here. I'm going to switch the color and just help you deal with the fractions here. So let's say I had 1 over a divided by 2b. So here a is taking the place of sine x and b is taking the place of cosine x. I have 1 over a divided by 2b. That's the same as 1 over a divided by 2b. And when we divide a fraction, we multiply by its reciprocal, so that's 1 over a times 1 over 2b, which is 1 over 2ab. The shortcut way I'm doing that is I just take the numerator here and multiply it by the denominator here. So the sine x came down to the bottom in a similar way, justified here. Okay, so I've got 1 over the sine of x times 2 times the cosine of x. And if we just change the order, you can see that it's identical. 1 over 2 sine x cos x. Now, as soon as you get to a point where you've manipulated the left side and you've manipulated the right side and they come out identical, you've proven that the left is equal to the right. So this is proof that the cosine of 2x is equal to the cosine of x divided by 2 times, the cosecant of x divided by 2 times the cosine of x. You can pause it here if you want to copy that out. Okay, now let's look at this one here. So we're now going to consider the cosine of 3 pi over 2 plus x, and whether that's equal to the sine of x. So I'm going to split the two sides. On the right, I'm just going to leave that as the sine of x. On the left, I'll see if I can manipulate this until it becomes the sine of x. So the cosine of x plus 3 pi over 2. So I have the cosine of the sum of two angles. And if you look at this formula sheet, the cosine of the sum of two angles is cos A cos B minus sine A sine B. So I'm going to apply that here. So this is cos A, where A is 3 pi over 2, times the cosine of B, which is cos x. And then that is minus sine A sine B. So this is minus the sine of 3 pi over 2 times the sine of x. Now, how can all of this become equal to the sine of x? Well, let's have a look at our Cartesian plane. That's 0 degrees. This is pi over 2. So that's 2 pi over 2. And down here, we're at an angle of 3 pi over 2. Remember, you start here and you go counterclockwise. So that's pi over 2, 2 pi over 2, 3 pi over 2. Now here, we have an r value, and our y value is the negative of our r value, and our x value is 0. Remember, the sine of our angle is y over r, and the cosine of our angle is x over r, where x is 0 and y is negative r. The cosine, which is x over r, is 0. So the cosine of 3 pi over 2 is 0 over r, and whatever r is, that's going to be 0. So I have 0 cosine x minus the sine of 3 pi over 2. And the sine of 3 pi over 2 is minus r over r. So minus r over r, where r is any positive number here, times the sine of x. Well, if you look here, minus r over r is negative 1, times negative 1 is positive. So all of that is equal to sine x. So maybe you want to pause this here. This is our proof that the cosine of 3 pi over 2 plus x is equal to the sine of x. As you can see, they're the same. Okay, now let's prove this third one. So I'm setting out to prove that the cosecant of x divided by the cosine of x is equal to the tan of x plus the cotan of x. The cosecant of x is, as we've said before, 1 over the sine of x. So I've got 1 over sine x on the left divided by the cosine of x. So this is 1 over the sine of x times the cosine of x, for the reason outlined earlier about dividing by fractions. I think I erased that. You can back up the video if you need a little more support in terms of fractions over fractions. Over here, the tan of x, remember the tan of x is the sine of x over the cosine of x. And the cotan of x is the reciprocal of the tan of x, which would make it the cosine of x over the sine of x. Now I want a common denominator here. So I'll multiply this top and bottom by sine x. And the reason why I want a common denominator is I want to combine these two fractions. I want to be able to add them. I'll multiply this top and bottom by, so I've multiplied that top and bottom by sine x. I'm going to multiply this top and bottom by cosine x. Okay, you can probably see where this is going now. Here we have the sine of x squared. Now there's a peculiar way we write that in trigonometry. We write it this way. That does not mean that the sine of x is being applied, that does not mean that the sine function is being applied to the sine of x. This indicates that we have the sine of x all squared. So I've got the sine of x squared over sine x cos x. And over here I've got the cosine of x squared over sine x cos x. So I have the sine of x squared plus the cosine of x squared all over the sine of x times the cosine of x. Now, have you seen this before? The sine of x squared plus the cosine of x squared. That's the Pythagorean identity. The sine of x squared plus the cosine of x squared is equal to 1. So that's 1 over the sine of x times the cosine of x. Now, as you can see, the left and the right side have been transformed into exactly the same form. So we've proven that they're equal to each other. In this case, just because I'm old and I've done these a lot of times, I've made the manipulations that brought them closer to each other. As you're starting out, you may make manipulations that bring the one trig expression a little farther from the other, and that's okay. If you do that, just keep looking for more identities and keep manipulating it, and eventually you're going to see that they both become the same. Another sort of plan of attack, you could continuously manipulate one until it becomes the other. I always find it much easier to manipulate both of them until they become equal to each other. Best of luck.